In this video, we're going to look at the 6 different types of formula that we use throughout AQA A-level Chemistry, and organic chemistry in particular. So first off, what is organic chemistry? Well, organic chemistry is the study of the structure, the properties, the composition, reactions and preparation of carbon-containing compounds. They're called organic compounds because originally scientists thought that they could only be made by living things, but we now know that that's not true. So basically, this is carbon chemistry. As I mentioned, there are 6 different ways that we can represent the structure of an organic compound, and I've listed them here in the same order that they are in the specification. But actually, we're going to start with the molecular formula because that's probably the most familiar to you. So a molecular formula tells you the total number of atoms of each element in a compound. So if we take C10H20, that tells me, because this is a small molecule, so I know I actually do have those atoms, I've got 10 atoms of carbon bonded to 20 atoms of hydrogen. Since molecular formulae are already quite familiar to you, we're going to jump straight in with a progress check. So there are 4 molecules drawn here. Pause the video and write down what you think the molecular formula of each one is, and then we'll come back and check them together. So the first one should be a very familiar molecule. This is methane, and its molecular formula is CH4. Next we've got methanol, and you should have CH4O. Now, there's a pretty good chance that you might have written down CH3OH, and if you've done this, then I'm afraid that's not correct for the molecular formula. What you've done there is a really common, really useful thing that chemists do, which is that you've pulled out the functional group on its own so that we can see it. And to be honest, that's what we do a lot of the time. But this is what we call the structural formula. If you're asked for the molecular formula, it should just be the ratio of those elements in the compound. Next, we've got ethene, and this is going to be C2H4. And then finally, we've got this dicarboxylic acid, and this is going to be C3H4O4. And again, you need to be just giving the ratio there. So some of you might have done something like HOOC CH2 COOH, and I completely understand why you would do that. That would be my instinct if you just asked me for the formula. But since we're looking for the molecular formula, we just want the ratio of the elements. We're now going to go back to the first item on the list. And it's entirely possible that you've made it the whole way through GCSE chemistry without having heard of empirical formula. It used to make up a much bigger part of the quantitative chemistry topic in the old spec, but now it only gets a very brief mention with ionic compounds, and many people just skim right over it. So what is it? Well, the empirical formula is the smallest whole number ratio of atoms of each element in a compound, and smallest is really important here. So if we take our original molecular formula of C10H20 and we take that 10 and 20 and put them as a ratio to each other and then simplify it, we would get 1 to 2. But we don't just want a ratio, we want a formula. So we write it like the molecular formula with the symbols of the elements and the numbers to show how many of them there are, but we're now using that 1 to 2 ratio, so it becomes CH2. So let's pause the video again while you check that you can deduce the empirical formula from the molecular formula, and then we can go over the answers. First of all, we have heptene, and this is going to simplify to CH2 again because it's still an alkene. Then we have C6H6, which will become CH. Glucose is going to simplify to CH2O. Then we have ethanol. So if first of all I put that as a molecular formula, so C2H6O, this makes it a little bit easier to work with, but I can see here that that's not going to simplify any further because I've only got 1 oxygen atom in there. So the empirical formula is going to be the same as the molecular formula there, C2H6O. And then finally, we've got some dichloroethane, and that's going to simplify to be CH2Cl for its empirical formula. So next we're going to look at the general formula, and you would certainly have heard this term if you did AQA GCSE chemistry or combined science with reference to the alkanes and maybe the alkenes. So a general formula applies to the whole of a homologous series. So that could be something like alkanes or alkenes or alcohols, and it describes their general chemistry and it makes it very clear what the functional group is. So for alkanes, our general formula is CnH2n plus 2, whereas alkenes, we don't have that +2 on the end, it's just CnH2n. And for alcohols, one of those hydrogens is replaced by that OH hydroxy group. So if we think again about our C10H20, we can see that this is an alkene, and therefore its general formula is CnH2n. Next up is structural formula. So when we looked at molecular formula, I mentioned that separating out the OH functional group, that would count as a structural formula rather than molecular. So the structural formula is when we write out the formula in a way that shows which atoms are bonded to each other. So for instance, CH3OH, that would be the structural formula, whereas the molecular formula would just be CH4O. Or if we think about a carboxylic acid, we're separating out that COOH to show that we know what a carboxylic acid is. Or if we think about that alkene that we were working with, that decene, then writing it out as CH3s and CH2s. Now you might also see sometimes when there are loads and loads of CH2s in a row like this, then to make it a little bit shorter and neater, you might see it abbreviated like this. The displayed formula is the one where we start drawing out the entire molecule, showing every atom and every bond. So for decene, it might look something like this, but you might also see it drawn with the carbon chain starting to form a zigzag because we're trying to sort of show how the atoms are actually arranged in space. And this is going to make it a bit easier to understand what's going on when we draw the skeletal formula. But before we get to that, it's really important that in this displayed formula, you are showing every single bond in the molecule. So a really common mistake that we see all the time that loses people marks is them drawing something like methanol like this. And that looks like a nice neat structure. It has all of the atoms, but what it doesn't have is all of the bonds. So they've drawn the OH together as one entity. And this is fine if you're just drawing a sketch to sort of show the examiner what molecule you're talking about. But if you have been asked to draw the displayed formula, then you must draw every bond in the molecule. So that includes the bond between the oxygen and the hydrogen in the hydroxy group of that alcohol. Finally, we've come to our skeletal formula, and this is this simplified displayed formula. So we skip out any hydrogen that is bonded to a carbon, and we draw a zigzag line which represents the carbon chain, and any corner represents a carbon. So this can be a little bit confusing until you get used to it, but it's quite simple really. So if we think about our decene that we've been using as an example for this, it's got 10 carbons. So I'm going to start with a little dot. I wouldn't actually draw a distinct dot, but just so you know what's going on. So that first dot is carbon number 1. And then I draw a diagonal line to my next dot, that's carbon number 2. So this single straight line represents 2 carbons. Right now I've basically drawn ethane. And then I carry on my zigzag like that all the way until I get to carbon 10. So you can see here I've only actually got 9 lines because it's the corners that are the carbons. Now in this instance it was decene with a double bond between carbon number 10 on the end and carbon number 9. So I would then do the double line to represent the double bond. And I don't need to draw in any of the hydrogens because it's kind of taken as read that they are there. So you're now going to pause the video and have a go at drawing the skeletal formula for these 4 molecules. Starting with propane, you should have the zigzag. Hopefully you remembered that it's the corners that are the carbons, not the lines. So you've only got 2 lines forming an upside down V rather than 3. Then our butene. Now we've got our 3 lines and we've also got that double bond in the middle. Then we've got pentanol. So here you've got 5 corners worth of carbons, and then we've got OH at the end. And for the skeletal formula, it's fine for us to have the OH together. We don't have to draw the bond like we did in the displayed formula. And then finally, you've got some cyclobutane. So you're literally just going to draw a square. Thanks very much for watching, and I hope that you found this useful as you start your journey in AQA A-level Organic Chemistry. If you did find this useful, then don't forget to like and subscribe for more A-level chemistry videos coming soon.